So our starter today is to talk about work, and I'd like you to define work in words, in pictures, and equations. So I'll do that for you in a minute. And then just work this problem. You don't have to copy the problem, but do use given, find, and solve with the sketch. And figure out how much work is done. Okay, so if you're watching this online, pause the video now, do the starter, and unpause it when you're done. So, now. Okay. So, let's define work in words. Work is when is, well, what any of you put anything interesting? It's a transfer of energy. Did you call it a transfer of energy? By a force. So we talked about energy transfers before. Work, waves, electricity, that sort of thing. Work is when we transfer energy by applying a force to something. And here's a picture. And this is the picture I'm going to draw. You could have drawn something different. Imagine a crate on wheels or something, and someone is pushing on it with a force, and it moves through a displacement, which kind of implies the equation that work is equal to force times displacement. And one of the things I asked you to do is to put arrows on it. So if the force is to the right and the displacement is to the right, then they're both doing positive work. I mean, then positive work is being done. If the arrows are in opposite direction, then the force is trying to take energy away from the object. Oh yeah, I'll hand that back to him.
I don't know if we need those.
Nah. So let's do the problem now. We have a car is pushed by a force of 500 newtons for 30 meters of displacement. How much work was done? So here's our car, and I like to draw pictures. There's a nice car, and we're applying a force to it. Maybe we're pulling or pushing. It doesn't matter where you put the arrow. Put the arrow back here or like that. And so our force is 500 newtons, and our displacement is delta x equals 30 meters. And so notice what I'm doing here. I'm expressing what's given in terms of the variables we use. We use F to represent force, and we use delta x to represent a change in position or how far we pushed the object. And around a picture, so it's easier to visualize. And we're trying to find the work done. So you just have to put W for work. Then we use the equation. When we solve it, work equals force times displacement. Always put the equation first. Then plug in the values. Okay, we're applying 500 newtons of force times 30 meters. And then we're ready for our answer. 3 times 5 is 15, but how many zeros do we have? 1, 2, 3. So don't really need a calculator to do that one. And then what is this? What is a newton times a meter? Yeah, it's a joule. So you had to know that. And then you put a box around your answer. So a very simple problem. Work equals force times displacement. I give you the force, I give you the displacement, you multiply, you get the answer. And some students would take a problem like this and they would just go, 500 times 30 equals, 15,000. And they would just leave it like that, and that's all they would show. And obviously the student knows something, but this is bad technique. And at this point, look, I don't really care about the right answer that much. I mean, I want you to get the right answer. You'll get credit for getting the right answer. But a problem like this on a quiz is going to be worth 5 points maybe. The right answer is only worth 1 point out of the 5. Using proper technique is going to be worth the other 4 out of 5. Now, the advantage of that is you can get the wrong answer and still get 4 out of 5. Okay, but this will be very useful to you in the future. Scout's honor. Okay, that is all.